Hello guys, in this example, I'm gonna do a simulation in Matlab for one of the examples that we have been working with, and that is the serial 2 degrees of freedom rotational robot basically. So this is a robot that I have, and I would like to be able to simulate that. All right. We said one of the first things that you want to do is, if we are using the DH convention, we're going to place our z-axis. So this is my z0, this is my z1, and then this guy is my z2. And then I have my x0. I'm free to choose this guy, whatever that I would like that to be. And then I have my x1, and then I have my x2. The origins of the frames are going to be O, O1, and this guy O2. Then I'm going to put my angle. So I have here theta 1, and then I have theta 2. Theta 1 is the angle between x0 and then x1, and theta 2 is the angle between x1 and x2. And I'm going to put some geometries on this robot, and I'm going to call this length L1, and then I'm going to call this length right there to be L2. And I'm not calling any offset between these guys. So all this manipulator is essentially moving in one plane. What I would like to do right now is I would like to go ahead and simulate that in Matlab. And we said that if I want to, for that in Matlab, just to kind of get an idea of what we're trying to do. So in Matlab, I would like to be able to simulate, like, theta 1 as a function of time. So I'm gonna input this guy, right? So I'm gonna specify what f of t is, and I'm gonna do theta 2 as f2 as a function of time. So let's call it, all right, so theta 1 is gonna vary as a function of time. It could be like sine t, and theta 2 could be like a cosine t, for example. And when I run my script, I would like to visualize how this robot moves. This is called forward kinematics because we are providing the angles thetas, and we use forward kinematics to obtain the position of O2, right? All right, to obtain the position of O1, I know I'm going to have to do what? HO1. HO1 will basically have R01 in it, and it would also have what? O1 in frame 0. So I'm going to be able to collect the position of point O1, right, which is the origin of the second frame in the base frame. And then I'm going to do HO2 is going to be something similar. It's going to be, nope, let me just do H1, right? It's going to be R12, O2 in frame 1, 0, 0, 0, and then 1. Ultimately, I'm interested in obtaining H01, which is H01 times H12, right? But I'm not going to calculate this rotation matrix. I'm simply going to use the DH transformations here, which we know basically A will be equal to L1. Alpha is going to be 0 because the angle between the z-axis is 0. There is no offset, so D is 0. So we will only basically have theta. So let me go ahead and jump into Matlab so we can see how we can do all this together. So I'm going to stop this. I'm going to come to my Matlab. I'm going to share. Okay, so this is my Matlab, and what I would like to do is, let me also make sure that I'm sharing my whole screen so we can see any scripts that we have. All right. So this is a Matlab script, so I can write my commands in a script and run them. It's like I'm executing them in a command window. All right. So we said the first thing that you want to do in Matlab is you want to write your name, and let's call this class tutorial. Okay. On simulating 2 axis planar RR robots. RR meaning it's a rotational robot. Okay, and I'm gonna have to save that, right? So I'm gonna save this as a class tutorial in my directory where I have all the functions, and I have already actually put my DH function. Basically, I have programmed my DH to accept A, alpha, D, and theta. And I could provide these as symbolic variables, or I could provide them as actual variables, and then I'm going to be able to use that DH function in my script. So the first thing that you want to do is you want to type CLC. It will clear the command window. So if I have anything on the command window, it will clear it. And then I'm going to clear variables, basically. So it will clear the previous variables. If you run that, you see basically I just cleared my command window. And the third thing that I'm going to do is I'm going to specify the geometry of the robot, right? So we said you know, we can use, we can write this like DH parameters, right? Or you know, DH parameters for each link. So I'm gonna A1 basically is for link 1. So in my case, A1 is gonna be equal to L1. So let's call L1 to be equal to 1, and L2 is equal to 0.5. Okay, and then these are immediate, for example, or in inches, whatever it is. Basically, the units will be consistent. So A1 is going to be equal to L1, right? As part of my DH parameters. So A1 is the distance between the z-axis. So the DH will take here, right? So A, alpha, D, and then theta, right? What is alpha? What is alpha 1? Is 0, right? Because the angle between the z-axis is 0, right? What is my D1 is also 0 because there's no offset, right, between the x-axis. And then what is theta? Theta 1 is actually it's a symbolic variable. So you know, I can do this. Theta 1 is equal to theta 1, but I'm going to have to define what theta 1 here. So I'm going to define it as a symbolic variable. I'm going to do sims theta 1. Okay, so this is a symbolic variable, and I'm gonna have to put semicolons so I can suppress the output. So here, this is simply telling me that this is not necessary, right? But I'm gonna keep it like that, just to stay consistent, to show you all 4 variables of this DH function. Okay, so here I'm gonna do link 1, and then I'm gonna do. So I could do this, or I could simply do that, right? So that way I can save some space. Okay. Now I'm gonna have link 2. And by the way, obviously, when you put this percentage sign, basically, it will not compute. It will not run this code, basically, right? So now let's do A2 is equal to how much? Is equal to A2, L2. Shit. So this is L2. Alpha 2 is also 0. D2 is 0. And theta 2 is equal to what? Is equal to theta 2, which is already a symbolic variable. Okay, so you can do this, or you can also remove these altogether. Okay, so you can remove this. Okay, so now I have my DH functions, and I can actually now write H01 is equal to what? Is equal to DH, right? A1, alpha 1, D1, and then theta 1. So this is my H01. Now H12. So make sure this is not H02 here. It's H12, and then it's equal to DH. A2, alpha 2, D2, and then theta 2. So now if I run this, so it run correctly. So I can actually, if I want to see what H01, I can remove that, and then I can see my homogeneous transformation for, you know, between frame 0 and frame 1 is the following. And because L1 is equal to 1, so this is going to be, these are the coordinates of the origin of the second frame. In the first frame, so I can do that, or I can directly call it from here. So I can do, so that. I can do okay, H01, and I can also do H12, right? H12 basically, this is 0.5 cosine theta 2, and then 0.5 sin theta 2, because I've already specified my link length to be 1 and then half. I could, for example, try and then keep that symbolic, right? So I can keep L1 and L2 symbolic. So I will just, you know, remove them here. Control R will help you to quickly remove, basically add the percentage, basically, or you know, kind of exclude the code. So here, if I'm running that, you see that H01, you're ending up with L1 cosine theta 1 and then L1 sin theta 1. Let me actually quickly come back here, and then I want to open this. So which makes sense, right? So what is H01? Basically, O1 is equal to what? L1, right? What is the x-axis? What is the x component of point O1? It will be L1 cosine theta 1, and then the y component of that is going to be L1 sin theta 1, which you would see clearly here in H01. And then if I want to do the second one, basically, right, what I would get, so if I want to express this guy in frame 1, I'm going to do L2 cosine theta 2. So the x1 component of point O2 will be L2 cosine theta 2, and then the sine component of point O2 in frame 1 will be L2 sin theta 2, right? Let me come back here, and then remove this video. Okay. So let me now try and then get H02, which is the overall transformation. So H02 is going to be equal to what? H01 multiplied by H12. Okay. So now let me run that. So if I do that, you are basically getting this guy. Okay. So one thing you do is you can also simplify that if you want, right? So to simplify the trigonometry of this function, and now it kind of make more sense, right? Why? Because H02 will be what? L1 cosine theta 2. I'm sorry, L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2, which kind of makes sense, right? So if you look here, basically, right back to my figure, if I have H02, if I'm trying to express a coordinate of frame 2, the x component of frame 2 in the base frame, it will be what? L1 cosine theta 1, right? And this guy is going to be, so if I actually build this angle is going to be here, theta 1, right? So it will be L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2, right? And then similarly for the x-axis, okay? So this is, okay, so let me turn off my video so we're all clear on that, right? So this is my H02, all right? So H02 will actually give me the coordinate of this point directly. Simply by using the DH transformations, basically by compounding these DH transformations, I'm now able to obtain the coordinates of any center of any frame, basically, with respect to my base frame. All right, and this guy is going to be my rotation matrix, basically, and then we are good to go from here. So let me here continue with this so we can try and then plot this robot, basically. So this is my H02, and if I want to actually get O1x, basically, what is O1x? O1x basically is the x position of point 01 in frame H01, right? So this will basically be what? H01, oops. So H01, and you know, I can basically pick up any value on my matrix, basically. In Matlab, basically, the first index here is my column, so I can do H1 and then 4. All right, so let's run that and then see what happens. So if I run that, basically, which makes sense, right? So the x component of frame 1 basically is L1 cosine theta 1, and I can do O1y. That's going to be what? H01 second row, fourth column, right? Okay, so let's also take a look at that, making sure, okay, so this is all good. Now I need to get the origin of the second frame, basically frame 2. So I can do O2x, and then this guy is O2y, and this guy is what? HO2, right? So HO2, and then I'm gonna basically calculate all these, which makes sense, right? So, okay, so this is not simplified, so you can simplify that if you want to make more mathematical sense of what you are seeing here. Simplify will always try to, you know, simplify the trigonometrical, basically, and other things that you could simplify as part of the equation. Okay, here we go. So O2x is equal to L1 cosine theta 1 plus L2 cosine theta 1 plus theta 2. Right here, this is the absolute angle, right? And then this is O2y. So now if I want to actually plot the robot, all right, how can I plot the robot? If I want to actually plot the robot, let me reopen my video so I can show you what I mean by that. So now basically, let me go here. So this is what we have done so far, right? So we have, you know, we're working with this basic robot, right? And then we know this angle here is equal to theta 1, and then we know this angle here is theta 2. We know this angle here is also theta 1, right? Because this guy is equal to this guy. We know the origin of this point is equal to O1, and the center of this point is equal to O2. Okay, so this is the point O2. And actually, I have O2x, O2y, and I have O1x, O1y. And then this point is 0, 0, right? And this point is point O, basically, which is origin of this frame. And then this is my x, and then this is my y. If I want to plot that, there is a function in Matlab that I can basically plot a line in Matlab. And if I want to plot a line in Matlab, right, the function is like that, and the line is, you know, is an object. And Matlab is object-oriented language. Basically, you could have different things, right? And then each one is an object, and then you can apply things to an object and then modify an object. So the line, basically, I can call link one, right? It's actually, so if I want to plot this guy, it's going to be a line, right? And then basically, the line is going to be made out of 2 points, right? So it's going to be x1, x2, okay, y1, y2. So if I do this, basically, MATLAB is going to plot me this line. Let's try that. And then if you're not sure with it, so we can do help line, and then MATLAB has a very nice feature of actually telling you how to actually plot a line. So line x, y, add a line vector x, and then y to the current axis. Okay, well, let's test it first and then make sure that this is what we're trying to do here. Okay, let me stop my video, and then I'm sharing my screen. Let me clear the command window, and let me bring this guy back here. Here we go. Let me first do it as a line, just as a test. So let's plot a line that has x of the first point is 0, x of the second point is 1, right? And then, so here I'm plotting a line from the origin to point 1, 1, right? So 0 and then 1, right? If I do this, let's do that. Okay. So basically, I just plotted a line, right? And then we're gonna call the link basically to be simply a line. I can also set my x limit on the curve or on the graph, basically, make it -1, 1, so we can better see that. And then I can do y limit, and this guy is also -1, 1. Here we go, basically. So we did that, and now I can try and then replot this, see how does it appear on that. So basically, I could use these functions to be able to basically be able to set up my x limit and then y limits on that. So let me actually do this as part of my as part of our script. Okay. Okay. So that's not what we're doing here. Okay, so let's plot link 1, and I'm gonna call link 1, right, to be a line, right? So link 1 basically has an origin of 0, right? So 0, O1x, and then it has a y component of 0. So the first point has, so 0 and then 0. So this guy, like I said, so this is a x coordinate of the first point of the line. This is a x coordinate of the second point on the line. This is a y coordinate of this first point on the line. And then now I'm going to have to do O1y, right? So if I basically do this, I'm going to be able to actually plot this, right? Unless we have some error, which looks like we do. Okay, so here basically, when you are plotting a line, you can't obviously plot a symbolic variable, right? So let me remove these guys. So Control T will actually undo this. So now I have a value for L1 and L2. So it looks like it's still taking that. So let me actually remove this from here. Okay. Okay, let's check what O1x is. So O1x, okay, so it's taking theta 1 as a symbolic variable. Okay, so we can, we are doing this guy. So O1x is L1 cosine theta 1, right? So now we actually have to provide a value for what theta 1 is. Okay, so here what I will do is I'm gonna actually write theta 1. I'm gonna give it a value. So let's plot it at 0 degree, and then theta 2 is also 0 degree. Okay. Okay, so if you do this in MATLAB, it will still actually take O1x as that. So you actually have to evaluate that. So one thing we can do here is, so O2x here is basically a symbolic variable. It still has a symbolic variable. So one thing you will do right now is you have to basically type evaluate O2x. So now it will actually compute whatever symbolic variable you actually have in that. So let's do this O1x here because we're doing the first one. So O1x and O1y is going to be equal to evaluate O1y. So this guy should be O1x. Let's also test that. So if you have, a variable which is a function of another symbolic variable. If I do theta1 is equal to 0.5 and then rewrite O1x, it will not take that, right? Why? Because O1x is already provided to you in terms of symbolic variable. So this setting theta1 to be equal to 0.5, it will not readjust O1x. So for you to evaluate, for you to basically change the symbolic variable into what is the actual value for this variable, you have to actually evaluate that. So you evaluate O1x, and now basically it's doing that. So it's actually computing the actual value for this. And the reason why we're doing that here is because we don't want to every time to recalculate the DH parameters. So you did the DH parameters once, and now you can evaluate that. So if you run that, it should be able to run. And let's see the figure now. Here we go. So this is the figure. So here, basically, I'm plotting on the same figure. What should happen here is basically every time you run a script, you should actually clear the figure that you previously have. So here we go. So now we are plotting the first link of this robot. Let's quickly plot the second link in the robot. We basically have to evaluate O2x and then O2y. So I could do this, or I could do and copy that very quickly. And then I have my O2x, I have my O2y, and now when I evaluate these two, O2x, and then this is my O2y. Let's quickly do link 2. So link 2 is equal to a line what? That starts basically at O1x, right? O1x, O2x, and then goes to O1y, and then O2y. Okay, so basically now we have a figure that has basically two links on here, and then this is obviously, so this is the first thing, and then this is the second link. What I can do now is, this is my theta1 and then my theta2. So I can basically make my theta2 power 4, right? So let's run that. Okay, so it looks like I don't have to do that here. So this is my link 1 and then my link 2. So if I want to actually visualize that, what I can do is, I can actually write a for loop, right? So I can write a for loop in Matlab, and then the way you write for loop, you can do it like that. So this is a loop that runs 100 iteration, and now I'm gonna end it here. So if I run that, basically now I'm actually going to be able to change these values. So what I'll do is I'm going to actually initialize a variable. I'm going to call t is equal to 0, and then my dt is equal to 0.1. And as time runs, or as the loop basically runs, ideally when you have a loop, basically you want to indent this properly. So you have t is going to be equal to what? T plus dt. So when I'm basically running the loop, my t is incrementing by dt at every iteration. Okay, so here I'm plotting this robot, right? What I would like to do is, for me to be able to see what happens, I'm gonna basically pause, and then I'm gonna delete basically a link. So basically making it like an animation. Now I can actually delete the lines on the figure, right? So what happens here, basically, these are functions, these are constants. So what I can do right now is I can actually make this guy equal to power 4, for example, right? Times, let's say sine t. Okay, and then this guy is power 4 times cosine t. Right, so here as time changes, basically I'm varying these guys. I come here, basically, I compute what O2x, O2y are. So ideally, one way would be to basically to actually calculate what are the actual values for O2x and then O2y symbolically, and then I can put them here. I can plot, and then I can delete, and then let's actually try to plot that. Okay, so this is what is actually happening. So one thing we can do here is let us calculate what are the values for O2x and O2y before we do anything here, as symbolic variables. So before the loop, let me do this. I'm gonna come here and let's actually find out like O1x, O1y, O2x, and then O2y. So now I can basically replace these directly in my, no, not here. That's good, right? Okay, so let me copy all these. Then come back to my script, right? And instead of basically evaluating these, let's just kind of make that more simple on your end. So let me just do that. So this is my O1x. This is my O1Y. Then I have my O2X, and then finally I have this is my O2Y. Here we go. Just gonna okay, so this is what I'm doing here basically is as I'm running time, basically I'm increasing the time t. I'm getting my theta 1, theta 2. I got my O1x, O1, O2x, O2y. Basically now I should be able to basically plot these without a problem. So here we go. Basically you see basically as you are doing this how this link is moving. So what is actually changing here is that my limitations are changing. So I want to actually keep that constant. All right, and so what I'll do is I'm gonna make my x limit to be equal to 0, 2, and my y limit to be also 0 and then 2. Okay, so that way you will be able to see that how that guy is varying, and then here. Okay, so let's actually do minus so we can see it very well. So minus 2, minus 2, and let's rerun that. Here we go, basically. So we see basically how we're doing that. We can actually put a grid on this, grid on, and let's actually reduce the time constant a little bit, and let's pause a little bit less than that. It doesn't have to be like, you know, just so we can are able to see that. Okay. Okay, no, we're pausing a lot here. I made a mistake here, so let me stop this. So Ctrl+C will always stop your script in case you want to stop it. So here we go. Okay, so we can run it for more time basically. So this is called forward kinematics basically. So literally I'm providing thetas basically, and as a result of providing thetas basically, I can actually you know, change, I can basically kind of visualize the robot. Right, later on we're going to do inverse kinematics, and with inverse kinematics we're going to be able to see this. You know, we're going to be able to provide what I would like the robot to be here in this, you know, XY plane, and then the inverse kinematics will solve the thetas and whatever that you have here. Okay, I can also adjust the sketch. So I can make this guy 0.5. I can make this guy 0. I can make this guy 1. I can change whatever that I have here, right? This is how my theta is changing. I can kind of speed up this one, just increasing the frequency basically. You know, even more, maybe like, you know, 5 times what the other one is moving basically. So every time you have to run that, you have to basically stop this. Okay. It is also possible to actually change the line widths on here as well. I could also basically set the line widths on link 1 and also the line widths on link 2 basically using this function. I can kind of increase the link length so I can basically visualize what's actually happening. Yeah, so this is how I can basically change the link widths basically so I can better visualize what is happening. And this is what I'm basically doing. So here I'm setting the link, the line widths on link 1 to be 2. So let's make them equal. So I have 5 and 5, and let's also make this guy kind of running at the same speed. Let's check this out now and then see what happens. So okay, so there you go. So basically, you know, this is like, you know, kind of clear forward kinematics basically, where we are changing what we are basically visualizing the robot forward kinematics by specifying theta 1, theta 2, and then seeing what the robot is doing. Okay, guys, so this is a brief tutorial in Matlab. What I recommend that you guys do this on your own to make sure that you fully understand what is going on and experiment with this on your own as well. Okay, guys, so let me know if you have any questions on that. Okay, bye.